Good morning, ladies and gentlemen, and thank you for having me on this session. I'll try and be very quick. I'll be speaking on tackling flood challenges using geospatial solutions. My name is Joseph Aru. Um, I wear a coat of many colors, depending on the day of the week. I'm either a geospatial analyst, data scientist, flying drones, or working on climate change issues. I started using GIS actively, commercially in the year 2010. The same year, I co-founded a company where we did geospatial trainings and installations, just with GCIT. And 3 years later, I founded GIS Cleric International, a consultancy where I was able to deploy GIS for corporations and international organizations. In 2018, co-founded OEA Consults, Observatory Earth Analytics, primarily dealing with Earth observation, geospatial intelligence, and drone mapping. And in 2022, we set up the North American branch of the Observatory Earth Analytics to expand our focus to new and emerging markets. Now, back now to the issue at hand. Flood is it's an issue that I think has affected almost every living person at one point in time or the other. Think about the time you are on your street and the street is flooded after a rainfall, or you're in the car on the road that is flooded, or you're watching TV and you can see houses flooded. It's one of the world's greatest challenge. It's the most common natural disaster. Almost everyone has encountered a flood issue at one point in time or the other. This is even worse in urban cities, where, say, for example, Lagos, where despite dealing with traffic congestion, any day it rains, the road is practically unusable. It becomes worse to a factor of 10. And there are simple factors that have aggravated these issues of flood. How we build our houses, where we build our houses, where we dump our drainages, the issue of climate change, the way we plan our development, poor management, poor planning. These are things that they seem simple at first glance, but they are the major reasons why we have consistent issues of flood, especially in this part of the world. And to manage this flood risk, to ensure that the flood risk does not become a major issue, it is important that we use the correct data for us to be able to make correct decisions. We have issues. We've used drones, UAVs. They have become very useful for obtaining accurate spatial data. GIS has remained a very useful tool for deriving spatial intelligence with respect to flood issues. However, there is a major issue that has bedeviled flood management and flood planning in this part of our world. One of it is poor and inadequate data. Our inability to actually to get the good data, our inability to actually curate accurate and actionable data has remained a key challenge for us in Africa, Nigeria, especially Lagos. At no point in time can the government tell us how many people are consistently at risk of flood. There are assessments yearly on the settlements that are vulnerable to flood. But most times when the flood happens, we find out that even settlements that were not listed as being vulnerable turns out to be vulnerable. Properties along the line of flood, properties on floodplains, vulnerable properties to flooding, etc. These are data sets that are very useful in preparing a useful flood management plan. There's also the issue of consistent wetland encroachment, building of construction of buildings along floodplains, indiscriminate waste dump, very, very poor drainage systems and embankments, and the clogged drains. These are all flood management challenges that we are faced with and that bedevils us as African community. This is just a very simple picture of what I'm sure a lot of us have seen at one point in time or the other. We have drainages like this, the second slide, where the volume of water actually coming out of this place is not is more than the capacity of the drainage to handle. And the simple solution is just a flip. You get better resolution data. We're able to plan at neighborhood level, no longer the regional level at which you plan. You optimize your waste management system to ensure accurate collection. You innovate your flood management solutions, reclaim the wetlands, put in effective drainage systems. And it's assumed that when all of these things are in place, the issue of flood risk and hazards is going to be mitigated to a reasonable extent. So let's talk about the Lagos example. The Lagos problem is a data problem, and this is everywhere from the traffic to flood to waste to everything that bedevils Lagos is simply a data problem. Inability to have good data. How many people live in Lagos? Data on how many vehicles are in Lagos, drainages and all of that are things that have ensured that it is difficult for us to plan. People have argued with me that data do not solve the problem. Data is not going to fill potholes, it's not going to stop flooding, but I always retort to say, whether data does this or not, data has been known to influence planning, aid decision makers and influence perception. And if the data is right, chances are that the decision that will be taken to solve the problem will be right. A flood risk outlook for Lagos State. 26% of settlements in Lagos State are under consistent flood risk. And when I say consistent, it means every time it rains, there is a risk of flooding. Of this, 69% of the entire Lagos is under extremely high risk of flooding. Extremely. If you look at this map, it looks very there. But this is the reality of Lagos. When it rains, even for less than 30 minutes, the bulk of Lagos is flooded. 45% of Lagos residents are constantly at risk of flooding. What this means is 1 in every 2 Lagosians, is prone to flood risk. So if you meet 2 people this morning, 1 of them is prone to flooding. And then let's take a look at these very simple statistics. You quickly see that the population at risk is quite high. Adirami, Feludu, Mushin, Oshodi, Surulere, these are areas these are areas where the population is very high, and also the population at risk is as high. This is a picture of a flooding incident somewhere in Agege in Lagos. And despite the fact that we know that flood cannot be totally prevented, flood control measures can be adopted to minimize these damages. So let's get to the data problem. Every time I talk about the flooding issue in Africa, in Nigeria, by extension Lagos, I attribute it to a data problem. And the reason why I do this is because we've had several flood management interventions over the years, and they seem not to work. And why does this consistently happen? If you look at this chart by DHI Grass, from flood warning to flood maps, it tells you that it goes from forecast to information broadcasting. But the critical part of this entire flow is the data aspect of it, from the satellite tasking to the image capture to how you receive your data. The data we use in this part of the world for our flood management, for our flood prediction, for our flood modeling are very, very defective, very, very defective. Let me quickly show us the next slide so you take a look at this. On the left-hand side is the high resolution DEM 1 meter. On the right-hand side is the standard shuttle radar thematic mapping DEM, which is 30 meters. And sometimes the difference between flood predictions and vulnerability assessments is simply down to resolution. The US has 1 meter DEM across all of the USD digital terrain elevation data sets. In Africa, in the most of Africa, except you are using drones to fly your location or you're buying really expensive digital surface models from the image vendors like Maxar, Digital Globe, and Co. The best we can hope to have is the decimeter thematic DEM. And of course, you can easily see that if this is the best we have, our predictions, our modelings are always going to be defective. This is another example of a proactive flood extent mapping. This is, if you look at the date here, this is July, August, 3 days after, in August, 3 days after, 3 days after. This is a map showing flood extent mapping within 18 days in Myanmar. And this was done using ultra high resolution data sets. The flooded areas were delineated, the buildings at risk were delineated, and intervention can get to these people. You're wondering why it's not Lagos, you're wondering why this is not the same situation in Lokoja. It's because we have a data problem. I'm just going to put a few geospatial approaches. So these are some of the approaches that we've used in OAA to try to solve the flooding issue. One, this is the flooding mitigation in Adegiogba using very high resolution data sets. And what can we find there? We found that the areas where the road networks are actually constructed, they are the areas of high flood inundation, high flow accumulation, which means that every time it rains, this part of the road is going to continue to flood because the design of the road did not take into consideration the spatial nature and the topographic nature of the land with respect to flood mitigation. Another approach that we use, which has proven to be very effective, is using the analytical hierarchical process and multi-criteria analysis. The next two slides is going to talk more about this, but simply what this says is for you to actually be able to estimate flood risk, you must be able to estimate hazard and estimate vulnerability. While hazard is the degree of risk, vulnerability is how many people in the population at risk. And the flowchart on the right is a consistent model that will be used to collect data, process it, and model, assigning weights to all of these criteria for us to generate a flood risk. This is a site-specific flood risk analysis that was done. We flew a drone over a specific area in Lagos State, generated the flow accumulation, drainage density, slope, and all of the other data sets, and applied it to the analytical hierarchical processing model. We're able to delineate specific buildings that were at risk of flooding, specific buildings. And this model have been deployed in several other locations, both in Lagos and outside Lagos, where the data we collect is granular, is down centimeter level accuracy. And this actually helps most times for us to be able to predict the flood risk in those areas. For larger areas where it's almost impossible for you to get granular or very high resolution DEM, we use a variant of medium resolution DEMs, the 12.5 meter allospal SAR-DEM, the 30 meters SRTM, and then we'll combine this with several other factors like the land use map, the soil map, the weather data. We reclassify the DEM using what we call the agree method, bringing in actual streams into the DEM to make the DEM a lot more effective for planning. And then this is put through the soil water assessment tool, which is able to generate, the stream flow. If you look at the model here, it estimates rainfall, evapotranspiration, infiltration, surface runoff, and it's easy for you to use this to actually plan. Despite the fact that this is a medium resolution data set, the level of accuracy of the data, of the results that you get is much more better than just using a DEM alone to estimate flood risk, because this brings in several other components: the soil map, the weather data, the land use map. The DEM, as important as it is also fine-tuned and recalibrated to ensure that it meets the actual hydrological characteristics of that environment. This is another model using this hydraulic modeling, using this ETIOS vicinage, the Lekki axis of Lagos, where we're able to actually predict peak runoff using the hydrologic model. Now, these three examples have used high resolution, medium resolution data set to generate flood risk assessment in 3 different locations. But one thing that is critical to all of them is that the quality of data sets that goes into a geographic process, the mapping, the analysis is what determines the outcome. Analytical hierarchical processing and multi-criteria decision support system have shown itself to be very, very robust tools in flood assessment, in flood and vulnerability modeling. And this is the same thing we see when you deploy SWAT. SWAT also uses a variant of multi-criteria analysis because it brings in several factors to be able to predict your surface runoff, to predict length of overland flow and other variables that actually contribute to flooding. So closing thoughts. For us to actually be able to deploy GIS to giving us very good and actionable data, one, we have to get high resolution satellite data of these areas. There has to be satellite data assessment of flood potential in these areas. We can't continue to use low resolution defective data sets. Quantitative assessments of flood management plan must be put in place, and this must be closely monitored through implementation. We need to analyze the present condition of primary, secondary, and tertiary flood drainage systems within the state. This also goes down directly to the quality of the data that is going to be used, as well as the development of interactive web and desktop-based GIS database of flood risk and vulnerability, which can be communicated to the people via Amber Alert, via routine flood mitigation, flood warning systems, early flood warning systems, and all of that. My conclusion, my final thoughts is this. Just like I said earlier, ultra-high resolution elevation models and highly accurate spatial data sets remains the primary foundation of a flood mitigation strategy. This is still within the GIS. And what this is practically saying is, if you put poor data in the GIS, you're going to get poor results. And the reason why most of our flood prediction and modeling have remained defective and seem not to be able to solve the problem is because the quality of the data that we deploy in them is really, really poor. And by deploying a network of telemetric stations for recording hydrometeorological parameters, we can actually set up early warning and robust flood management systems. Extreme floods for different return periods should be utilized for the design of drainages and storm sewers. The engineers designed drainages and all of that without taking into consideration the peak flood events, the extreme floods in 25, 50, or 100 years, such that irrespective of how high the rain falls, the drainages are still able to contain the water. Provision of an early warning system is an effective strategy for disaster risk management. And this system improves preparedness for flooding, because when people are aware that there's going to be flooding, they can take actual steps to reduce their vulnerability. The things that are going to get damaged, the children that might be sick due to diarrhea or due to bad water, these things are easily managed because people have been warned ahead of time. And when they are warned ahead of time and they find this data to be accurate, they begin to trust this. So I hope I've not taken too much of the time. This is my last slide. So the primary consideration here is to ensure that for you to have good GIS data set, for you to be able to plan accurately, to deploy good geospatial solutions to flooding in Africa, we must begin to strive for good quality data sets. Thank you.
Yeah, thank you so much for that session. We're 1 minute behind time, but we are going to take one question. Do you, if you have any question that you want to ask the speaker, you can just drop them in the chat, or you can just drop them in the lobby. I think this is a very interesting point. So if you put bad data into the GIS system, the result will be bad. So I think that's the highlight for me for this event. Do we have any question? Okay, if you don't have any question, then we can all move to the next session. See you in the next session.